For more problems and videos like this for linear algebra, you can take a look at Sarai Studies, link is in the description box below. In the last video, we talked about row echelon form. In this video, we're going to talk about reduced row echelon form. So what are the conditions that a matrix must satisfy in order for it to be in reduced row echelon form? The first one is that it must be in row echelon form. The second one is that all of the leading entries have to be equal to 1. And lastly, each leading entry is the only non-zero entry in its column. And we'll see what that looks like. We call performing the steps necessary to get a matrix into this form Gauss-Jordan elimination. So we'll talk about that in an upcoming video, but for now, let's look at what matrices look like in reduced row echelon form. So here we have this matrix. It has to satisfy conditions A, B, and C. So first of all, it has to be in row echelon form. And recall the mnemonic that I showed you called ZO. So Z-O, which is really standing for a 0. Z stands for are all 0 rows at the bottom of the matrix? If yes, it satisfies. Does it pass a staircase hack? So I showed you that if the matrix passes a staircase hack, that means it satisfies condition B. And finally, the 0 are all entries below the leading entries equal to 0? Yes, so then it passes that as well. So let's actually apply that to this matrix right here. Are all 0 rows at the bottom of the matrix? Yes, because this is a 0 row and it's the bottom, it satisfies that first condition. Does it pass a staircase hack? What we need to do is identify the leading entries first. So remember, the leading entries are the first non-zero entry you see in a row. So this is the first number that I see in this row that's not 0. I go, 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 go. This is the first number I see that's not 0. That's my leading entry for this row. And then this one, all of them are 0. So there's no leading entry for that row. So for the staircase, I start with my leading entry and I go, go, go until I see another leading entry, and then I go down and then I go, go, go. So when the height is 1, that's perfect, because we don't like steep staircases, because if you were here and the staircase looks like this and you take a step, you're going to die. So we only like nice little 1 steps that we can take. So a height of 1. So because it passes the staircase hack, it passes condition B for row echelon form. And finally, are all of the entries below the leading entries equal to 0? Well, this is a leading entry. Are all of the entries below it 0? Yes. Leading entry, all entries below it 0? Yes. So it does satisfy this condition. So I know that this is in row echelon form. So it does satisfy condition A of reduced row echelon form, which is that it has to be in row echelon form. And then the other 2 things that we have to worry about is that the leading entries are equal to 1. And they are. These are leading entries and they are equal to 1. So this condition is satisfied. And finally, each leading entry is the only non-zero entry in its column. All that means is this here and this here should be the only actual number that's not 0 in its column. And that's true. The rest are zeros. So it's the only number that's not 0 in its column. So this condition is satisfied as well. So not only is this matrix in row echelon form, it is in reduced row echelon form. Now for the rest of them, I'm going to show you my full mnemonic, which is ZO plus 1C. So ZO is what I use to determine if a matrix is in row echelon form, and then the only thing that we're adding is checking that the leading entries are equal to 1, and that the leading entry is the only number that's not 0 in its column. That's where the 1C comes from. I also think of calculus where you have to add a plus C to everything, so a 1 in front of a variable is just the same thing as C. So that's how I think of it. But if you haven't taken calculus, it doesn't matter. It's just 1C. So are all 0 rows at the bottom of the matrix? Well, there aren't any 0 rows, so therefore unapplicable, so it automatically passes. Does it pass the staircase hack? Well, again, you have to identify your leading entries first. So you start with every row, you skip all the zeros until you get to the first number that's not 0, so that's going to be your leading entry. Go, 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 this is the first number I see that's not 0, so that's my leading entry. Go, 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 this is the first number I see that's not 0, so that's going to be my leading entry. Then you start with your first leading entry, and then you only go down when you see another leading entry, only go down when you see another leading entry. And because the height of each step is 1, it's appropriate, it's not steep, then therefore it passes the staircase hack. Finally, are all entries under the leading entries equal to 0? Well, this is a leading entry. Are all entries below it equal to 0? Yes. Leading entry, all entries below it equal to 0? Yes. This is a leading entry. There aren't any entries below it, so that automatically passes. So it passes this condition as well. So now we know that this is in row echelon form, but is it in reduced row echelon form? Well, are all leading entries equal to 1? They are. This is a 1, this is a 1, this is a 1, so it passes that condition. And finally, are all leading entries the only non-zero entry in its column? That's what C stands for, column. Check that the leading entry is the only actual number other than 0 in its column. So this is a column with a leading entry. Are all other numbers 0? Yes. This is a column with a leading entry. Are all other numbers 0? Yes. This is the column with the leading entry. Are all other numbers 0? Yes. So therefore, it passes this condition. And not only is this matrix in row echelon form, it is also in reduced row echelon form. Just know that when you say, hey, this matrix is in reduced row echelon form, it is automatically in row echelon form because it is a condition of it. Let's move on to another one. Are all 0 rows at the bottom of the matrix? Well, there aren't any 0 rows, so this automatically passes. Does it pass a staircase hack? Again, you need to identify your leading entries first. So for every row, you go until you see the first number that's not 0. So that's your leading entry. Go, go, go until you see the first number that's not 0. That's your leading entry. Then you go, go, go until you see the first number that's not 0. So that's your leading entry. Then for the staircase, you start with your first leading entry and only go down when you see another leading entry. Only go down when you see another leading entry, and then just keep on going, right? Is the height of each step 1? Yes. So it passes the staircase hack. Also, I want to note something I didn't mention in the other video. The width does not matter. It's just the height that we care about. So we can walk for a very long time. It doesn't matter. As long as the steps are 1, 1, and 1, we're good. Here, the width is 1. Here, the width is 2. But that's fine. It doesn't matter. Like, we don't mind walking. What we do mind is having a step that looks like this and having to go from here to here. We're gonna die, okay? So width does not matter. What matters is the height. We want height of 1, a step of 1. So this passes the staircase hack. And then finally, all of the entries below the leading entries have to be 0. So this is a leading entry, or all of the entries below it 0? Yes. This is a leading entry, or all of the entries below it 0? Yes. This is leading entry, but there's no entries below it, so we're good there. So it passes this condition. So therefore, because it passes ZO, this is in row echelon form. But is it in reduced row echelon form? Well, are all of the leading entries equal to 1? Well, this is a leading entry, it's 1. This is a leading entry, it's 1. This is a leading entry, but it's not 1. So it doesn't pass this condition. So therefore, it's automatically not in reduced row echelon form, because for it to be in reduced row echelon form, it has to pass both of these conditions. This needs to be a 1, and it's not, so it's not in reduced row echelon form. But let's check this condition for the sake of the video. So here you're focusing on the column, meaning that each leading entry has to be the only actual number other than 0 in its column. So this is a column. Are all of the other numbers 0? This is another leading entry column. Are all other numbers 0? No, there's a 2 here. And this is another leading entry column. Are all of the other numbers 0? No, there's a 2 here. So it doesn't pass this condition either. And finally, we have this matrix over here. Are all of the 0 rows at the bottom of the matrix? Well, there aren't any 0 rows, so not applicable. So therefore, it just passes this automatically. Does it pass the staircase hack? Again, you have to identify your leading entries for that. So for every row, you go until you find the first number that you see that's not 0, that's this one. Second row, you go until you see the first number that's not 0, that's this one. The third row, you go and you see this number, it's the first one that's not 0, so you select that one. Then for the staircase, you start with your first leading entry and you go, go, go until you see another leading entry. That's when you go down, but you keep going down and you go, go, go as soon as you don't see any more entries. But the problem is, if you are here and you're going to take a step, you're going to die. So this is too steep. It has a height more than 1. We don't like that, so it doesn't pass the staircase hack. So it's not in row echelon form. Let me add that here. So it's not in row echelon form, so that automatically means that it's not even in reduced row echelon form, because the condition for it to be in reduced row echelon form is that it's in row echelon form. So it's in neither. But just for the sake of the video, let's keep going and check all of the other conditions. Are all of the entries below the leading entries 0? For this one, all of them are 0, so yes. But for this one, we have a 1 here, so it fails this one too. Are all of the leading entries 1? Yes, yes, yes. So it passes this one. But then we focus on the column. We ask ourselves, well, is this one the only actual number other than 0 in this column? So this is the column. Is this one the only actual number other than 0 in this column? Yes. And then this is another column that contains a leading entry. Is this one the only actual number other than 0? Well, we have a 0, but then we have another 1. So no. So it doesn't pass this one either. So that's this video on reduced row echelon form. I will see you in the next.